Blockchain. You've definitely heard the word, probably in the same breath as Bitcoin. But what is it really? Let's just forget all the hype and the jargon for a few minutes. We're going to get right to the heart of what this technology is and why it's got so many people talking.
Okay, to really get blockchain, you first have to understand a huge problem with, well, the internet itself. Think about it. If you email someone a photo, you're not really sending it, you're sending a copy. Now you both have one. That's great for sharing pictures, but it's a total disaster for money. How do you stop someone from just copying a digital dollar and spending it over and over again? This is called the double spending problem, and for decades, it was the big puzzle blocking the way to true digital cash. So, here's our game plan. First, we're going to dig into that digital trust problem. Then, we'll look under the hood and see how a blockchain actually functions. We'll take a quick trip back to its origins with Bitcoin, check out the difference between public and private blockchains, and finally, we'll talk about the huge promises and the equally huge problems. Right, so let's dive into that core issue, the digital trust problem. It's one thing to solve double spending. We've had banks for that for centuries. But how do you solve it without a bank, without a middleman at all? That's the idea that changes absolutely everything. The solution starts with a pretty old-school idea, a ledger. Just think of it like a notebook where you write down every single transaction. But here is the magic trick. Unlike a bank's ledger, which is locked away in their private vault, this digital notebook is distributed. It's copied and shared across thousands of computers all over the world, and they all have to agree on what's written in it. No one person and no one company owns it. Okay, so how does this shared public notebook actually work? How does it stay secure? Well, that brings us to the mechanics of it all. And it really comes down to three things: blocks, the chain, and the network. So if the whole blockchain is the notebook, a block is just a single page. Simple with that. It's basically a container that gets filled up with a bunch of the most recent transactions. And critically, it also gets a timestamp, like when the page was finished, and a special, super secure cryptographic link to the page that came right before it.
And here's the process in 4 steps. First, you request a transaction. You want to send some money. Second, your transaction gets bundled together with a bunch of others into a brand new block. Third, that new block is broadcast to everyone on the network. And finally, and this is the important part, all those computers on the network have to validate it and agree that it's legit before it's officially added to the chain. Once it's in, it's permanent.
And that brings us to the chain part. Each new block is locked to the one before it with that cryptographic link, creating this long, unbreakable chain that goes all the way back to the very first transaction ever made. Now, here's the brilliant part about its security. If you wanted to go back and secretly change something in an old block, you'd also have to change the cryptographic link in the next block, and the next one, and the one after that, on thousands of computers, all at the same time. It's basically impossible. And that's the secret sauce. So where did this whole idea come from? It feels so futuristic, right? Well, let's jump into its origin story, from Bitcoin to beyond, and how one mysterious white paper kicked off a revolution. Believe it or not, the core concept is older than you probably think. All the way back in 1991, a couple of researchers, Haber and Stornada, described a cryptographically secured chain of blocks. But it wasn't until 2008 that all the pieces clicked together, when the anonymous person or group known as Satoshi Nakamoto published the famous Bitcoin white paper. And by 2009, the Bitcoin network was live, and the first blockchain was out in the wild. And this was the massive, world-shaking breakthrough. Bitcoin was the very first time anyone had successfully solved that double spending problem without needing a central authority. It was proof that you could have a purely peer-to-peer system for electronic cash where trust isn't put in a corporation, but in math and the collective agreement of the network.
But of course, the technology didn't just stop there with Bitcoin. The idea has evolved, which brings us to the ongoing debate over its future: public, private, and hybrid chains.
So on one hand, you have public blockchains, also known as permissionless. Think Bitcoin or Ethereum. It's like a public park. Anyone with a computer can come in, look at everything, and participate. On the other hand, you have private or permissioned blockchains. These are more like a country club, run by a specific group, and you need an invitation to get in. Companies might use these for things like tracking their supply chains.
And this has led to some really valid pushback. As Nikolai Hampton pointed out, a lot of these private, in-house blockchains, well, they might just be really slow, really complicated databases. The argument is, if you have a gatekeeper controlling who gets to participate, haven't you just lost the whole point of decentralization?
But the potential of this technology is now exploding far beyond just money. We're talking about things like smart contracts, which are basically agreements that automatically enforce themselves. It's being used for supply chain tracking. Walmart uses it with IBM to track lettuce from a farm to a store in just seconds. And of course, it's redefining digital ownership in gaming and art with NFTs.
Okay, that brings us to our final and maybe most important section. Big promises, big problems. Because for all the incredible potential we've just talked about, this technology faces some very real, very massive hurdles. And the biggest elephant in the room, by a long shot, is energy consumption. Right now, the Bitcoin network, just by itself, is estimated to use around 121 terawatt-hours of electricity every single year. That's a number so big, it's honestly hard to wrap your head around.
So let me put that into perspective for you. That is more electricity than the entire country of Argentina uses in a year. This unbelievable energy drain comes from the security model Bitcoin uses, called proof of work. It basically makes computers all over the world compete against each other, burning massive amounts of processing power to solve complex puzzles. This work is what keeps the network secure, but it comes at a staggering environmental cost.
And so we're left with this huge, critical question. Can a technology that was designed for a decentralized, open future figure out how to solve its massive energy problem? Will newer, more efficient methods prove to be just as secure? Really, the question is, can blockchain overcome its own success and actually live up to its world-changing potential? That is the big question mark hanging over its future.